Okay, so let's go ahead and start wiring the charts in our dashboard up to some actual data from the API. So for this, we're going to head into our sections and then into our section sales, and we'll take a look at the current state of the component as we left it, which is basically empty here. In the template, we can see that we're putting out some of our various charts. So we've got two identical pie chart components, a line chart that goes across the bottom of the page, and a bar chart at the top left. Let's work with our bar chart first. So I'm going to leave our section sales component template open, and then I'm going to go into charts and we'll take a look at our bar chart. So let's head into the template there first as well. So I'm going to leave the sales component template open, and we're going to now navigate into our bar chart component. And you can see here we have some inputs into our chart that we're setting with properties that are in the TypeScript in our component. So notably, this bar chart data corresponding to the datasets input, some labels, options, a legend, and the chart type, which in this case is bar chart type, set again in our bar chart component here as some various properties. And if you recall earlier in the course, we set up some sample data for our bar chart data and labels. And now we're going to replace this with actual data from our database. So in fact, I'm going to go ahead and comment out our sample bar chart data and sample bar chart labels, and then we'll remove them here, and we won't have any default value on these. So we're going to use the same service that we used previously to retrieve orders from our system, namely our sales data service here, to pull back data from our database. So if we head back into the component, as we've seen before, we can inject an instance of that service into the constructor of our bar chart component class. So we'll inject a private sales data service of type sales data service. And of course we need to bring that in. So we'll import sales data service from, and then we need to go up 2 directories to find our services directory and bring in sales data service here. Okay, so what I'd like to do now is to create some properties to contain the data that we'll be getting back from our sales data service. So just beneath the constructor here, I'm going to create a property orders, which for now will just be anything. We'll have order labels, which will be a string array. Then we'll have some order data, which would be a number array. And we can kind of see how that worked when we had our sample data. We had 2 data series in our sample data. For the chart that we're building now, we're just going to have a single data series. But you can see the data object here is an array of numbers, and the labels are an array of strings. So this label pertains to the particular data series. So if we were to have multiple data series, as we did in the example, then we'd have individual labels for each data set. But in a sense, we'll just have one series, and then that series will have some labels across the bottom of the sort of like the x-axis of the bar chart. So let's head back down into our ng on init method, and here we'll invoke our sales data service to retrieve some data from our API. So we can call upon it with this.sales data service, and we have our get orders method. And if you recall, get orders takes a page index and a page size as arguments. So we're going to get the first page of 100 orders, and by default our API returns orders by order placed date descending, so this will be the most recent 100 orders from our system. And that returns an observable that we can subscribe to. So let's go ahead and just subscribe, and then the response that we get back we can use. Once the response returns some value, we can use it to set the value on some of our properties. So let's just go ahead and console.log the response first of all, so that we can just kind of see what's coming back and refamiliarize ourselves with the structure of that response. Just going to head back over to the page, and we'll inspect and check out the console. So what we get back here is this object. We have a page. The page contains a data object and a total. object. The total is just the number of results in our database, and then the data that we're getting back is an array of 100 of these objects that contain information about each of the orders. So this is 100 order objects here. Notice that we also have the customer on these orders. So we've got quite a lot of data here. But the important part right now is to just recognize the structure. So we have this page object and then this data object, which is really what we're after. So we'll come back, and if we look at the response page and then the nested data object, this will show us just exactly what we're after. So here's our array of 100 order objects. So what I want to do is construct a sort of data structure for our bar chart where we group all of the dates in our array here by day, and then we sum the total for that day. And we can more or less disregard the other properties that are on these objects. So this is going to kind of give us an orders by day type bar chart. And as you can see, we're going to have to do a little bit of data manipulation here to kind of wrangle it into a structure that's useful for us. As you can see, first of all, we have this sort of timestamp, sort of standard UTC format, which isn't really particularly useful for us for a high-level view on our bar chart where we just want to see the particular day. So we'll have to do something about that. And then, of course, we'll have to do something about grouping all of the data, the orders by day, and summing their total. So let's take a look at how we can do that. First of all, to work with dates, I'm going to bring in the moment library, and we can import star as moment from moment. You should be able to find this in your node modules. We can expand that here and just take a look. Scroll down to moment and we see it here. So if this is not part of your node modules, then you should go ahead and install that with npm install -- save, and that will save moment, but that should be in your node modules. Moment's going to allow us to work with dates a little bit more easily than it would be to sort of work with them manually. So we'll go ahead and comment out our console.log now that we know the structure of our response. And what I'm going to do is create a constant, and I'm just going to call this local chart data. And we're going to create a method called getChartData that will pass our response. And what that's going to do is it's going to sort of parse the response and give us a data structure that we can use to set some of the properties that are used to build our charts. So let's go ahead and build that method, just getChartData. It takes our response, which is a type of response. So we know that the orders that we get are from the page object and then the nested data object. So this will return our orders array. So we'll set this.orders to that orders array from our response. And then what I'm going to do is to get the actual order totals out of that response, I'm going to create a constant data. And what we'll say is this.orders, and we'll use the map function here to get the order total from each of the elements in this array. And if you'd like to see what this is doing, we can once again just console.log and we can log data. So here's our data. So you can see that this is just all of those values for the orders from our orders array. The next thing I'd like to do is to create a constant labels to store those datetime objects. And as I mentioned, we'll be using moment to kind of wrangle those into something a little bit more useful, at least from a visualization perspective. So we'll once again look into our orders array, and this time we're going to map o.placed, so the placed value on each of the orders. So if we were just to see what that looks like, we'll console.log it and take a look. And you see we have this array of these somewhat unwieldy timestamps, date timestamps. So we can use moment to kind of clean those up. We can make sure that this is actually a new date just by specifying it as a date. And now if we look at our array, we can see that we have proper JavaScript dates for each of these objects. Still a bit unwieldy because we're really just looking for something like the year, month, day for our labels. So what we can do is we can wrap this date in, we can just pass it to moment. And what this is going to do is, first of all, now it's a moment object, but we have new methods on it now. So we can, for example, format this, and then we'll do year, month, day using this syntax. And now if we take a look at our labels, we can see that there are strings, and they just correspond to the actual sort of like string formatted date. So this is much more useful from a visualization perspective. And what we'll end up doing is grouping all the dates. So we have a date here for each order. And of course, now we have multiple of the same dates. We're going to group by the date and sum the value of the orders for that particular day for each date in this array of 100 orders. So we're going to do that using the reduce function. And just to get an intuitive sense of how reduce works, if you've not used it before, or perhaps you haven't used map before, the map, filter, and reduce functions are all really powerful ways to work with arrays in JavaScript. As you saw with map, we were able to take every element of orders and translate every instance of an object in orders to just receive the total from that particular individual order, and we kind of push that into its own array. So map's useful for sort of translating, if you will, every member of an existing array into something else. We did the same here. Filter will allow us to do just what it sounds like. We can filter for specific things within an array. And reduce is kind of a more general function wherein we can perform any arbitrary set of operations on every element of an array. So the classic example with reduce is a function that will sum all the elements of an array. I think this is the best way probably to explain reduce before we use it in a slightly more complex manner. So let's say that we have a constant myData, and we have an array of, say, 3, 4, and 5. And so we want some function to sum all of the elements in this array. Well, let's just go ahead and call reduce. And then reduce is going to take a callback function here where we have what's called an accumulator. Let's just call that sum. We won't worry too much about the nomenclature here. And then we have the current value, so let's just call that value. And let's just go ahead and write a simple function here. Maybe we'll just return the accumulator plus the current value. So I'll put curly braces around this. And then the second argument of reduce is an initial value. So in this case, our initial value will just be 0. And I'm just going to kind of clean this up a bit. Of course, we need to return some value. So what is this doing intuitively? Well, we've got this sum, and we have this initial value 0. So reduce is going to iterate over every element of the array that it's called on. And starting with 0, it's going to perform some function on the element in that array. So in this case, we have 0, so we'll say sum is 0, plus value, which in this case is 3. Recall that the second parameter in our callback function here is the current value. So going from left to right, we have 0 plus 3, so then we have 3. That return gets stored as the value of the accumulator. So now we have 0 plus 3 is 3, and then 3 plus 4 is 7, and then 7 plus 5 is 12. So you can see that we've just created a simple function to sum 3, 4, and 5, which is 12. And in fact, we should be able to see that if we console.log myData. We'll just label it so it's easier to recognize here. and we'll move it outside of our function. And for now, also, I'm going to comment on our labels. So let's take a look at my data. And indeed, you can see it's 12. So if you want to get an even better sense for what's going on here, we can even console.log inside of our reduce function. And here we'll just log the sum and the value. So you can see we start out with 0, and then we have the value 3. So the accumulator now has the value of 3 because we're adding it. And then 3 plus 4 is 7, and 7 plus 5 is 12, which is the final result after the reducer or the reduce function has exhausted our array. We get the value 12. So that's just the sort of the most simple sort of archetypal example of using reduced. But it's really powerful. You could actually manually create all of the other functions that you can do to an array using reduce. Okay, so what I'm going to do is I'm going to comment this out, and we can leave it here just as an example if you'd like to just continue getting a sense for how reduce works. I'll go ahead and grab this down here. We're going to use it to create a brand new array that contains a date as a label and the sum total of orders for that date from our original orders array. So let's start by creating a constant. We'll just call it dates. And what we're going to do is we'll take this dot orders and we'll call reduce on it. So now we'll be reducing across that array of order objects. We'll create our callback function here, and these are the two parameters, remember the accumulator and then the current value. We'll do something inside of our function here, and our initial value in this case will just be an empty array because in the end we want to have an array of these dates. So we'll start out with an empty array and we'll push some new dates onto this empty array. So for instance, we can simply say r.push, and we're going to use moment to push the date that the order was placed, and we'll format it as we had initially did when we used map to create our array. And then we're going to simply grab the total from the orders array. So now we don't even need our labels, so I'm going to remove that. And we'll name this something more descriptive. This is more like our formatted orders. So let's console log this and see what it looks like. But you can see that it's pretty straightforward. All we're doing is we're taking our accumulator, which starts out as an empty array, and we're pushing an array that contains a date and the order total for that date onto that array, and then here we're just console.logging so we can take a look. Oops, so we're getting an error, cannot read property push of undefined. So we need to return R here. That way, as reduce is iterating over it, we return the accumulator here so that we can continue building upon it. So now we should be able to see it. So here's our array of arrays that contain our sort of cleaned dates. So it's looking a lot better already. Now let's write a second reduce function to group by date and sum the order totals on each date. And we'll call this chart data, since this will be ultimately what we're using. Go ahead and delete our console log. And the way this will work is we'll say formatted orders, and we'll call reduce again, because we still have an array. We'll create our callback function. We'll do something, starting with an initial value again of empty array. So we're going to build a brand new array. And this one might seem a little complex at first, but once we work through it, you'll see that it's actually relatively straightforward. I'm going to start out with a constant key. And we're going to say that this is the index 0 of the initial value. So if you recall, the initial value of every element in formatted orders was that formatted date that we had as a string. So the key will be that formatted date. And what we'll do is, first of all here, let's go ahead and create an empty array, constant p, we'll say. And what we'll say here is if that key doesn't exist in our accumulator array, So in other words, not our key. Then we'll go ahead and make it, and we'll set its value equal to the current value that we're iterating over. And what I'm going to do here to kind of help us out is I'm going to create a constant p, also an empty array. This is just going to serve as kind of a helper here, and you'll see. So what we'll do is we'll say if this key doesn't exist in that array p, so in other words, if not p key, then we'll set it, so p key. We're going to set it to the current item that we're iterating over. And then we'll push onto our accumulator the value at p key. So that would be the order total. Otherwise, and in this case, this would be when the date actually exists in our accumulator array already, then what we're going to do is take that order sum, take that order total that exists at that key, and we're going to add to it the total of the current iteration. And that's it. After that, we can just return R. So it's actually a pretty simple function. If you just see it at first, it might be a bit difficult to follow. But if we talk through it again here, I think it'll help solidify what's going on. So we have our formatted orders. Let's just recall what that looks like. So here's our formatted orders. We have this sort of clean date. We have this sort of clean string to represent our date, and then we have the order total. Okay, so this might look a little bit confusing at first if you just kind of stumbled upon it, but we can definitely kind of see what's happening here if we just walk through it. So we have our set of formatted orders, which contains a date and an order total. And so then we can create a constant key here. And so for every element of that array, we have the current value, which is E. And so E with index 0 is that date. And we basically say if this empty array that we've just created at first doesn't have a key corresponding to that date, then set it equal to that object. Then we'll basically push the value, which in this case is the order total, onto our accumulator. Otherwise, if that date key already exists, then once again, we add the order total to the corresponding date key. And we return R, so ultimately we have some clean chart data. Let's take a look. And here we go. So you can see that we have these dates now in descending order where we summed all the order totals for each of those dates. So this is a perfect kind of format for us to actually build out our bar chart now. So rather than console log it here, we'll just go ahead and return it. So that completes the functionality of our getChartData method. So now in our ngOnInit method, what we can do is we can set this .barChart labels equal to local chart data, whose value gets returned from our getChartData method that we just wrote. And here we just want to grab the dates, so that's simple enough. We can just call map and go ahead and grab the first index, which is our dates. And remember, those are strings, so we have a set of strings here. And remember, those are strings, so we have, in a sense, just an array of strings here. And we're in descending order, so let's go ahead and reverse that for the purposes of our chart. We want to go from left to right in terms of time, so we'll start with the earliest date from our set of 10 group dates, so we can just reverse that array very simply. And then we can set our bar chart data. And recall that this takes this sort of object here, where we have an array that contains this object with a data property and a label property. So we'll come down here and we'll just construct it in place. So data will set to our local chart data .map, And this time we'll grab the first index as opposed to the 0th index. So the first index here being the second part of that array, which is our order total sum. And then the label, we can just say sales, something like that. Okay, so that more or less completes our chart. Basically, you can see just as a summary here, what we did is we used our sales data service. We got a response back from the server that contained this complex object of 100 orders. And we wrote this getOrders method to kind of wrangle that into a format that we could use to build out our chart data. And we did that for the most part using JavaScript's reduce function. Once that was complete, we use map to actually map elements in this cleaned up array into separate arrays for our bar chart label and our bar chart data object. And just to back up a little bit, our getOrders method returns an observable. So we set all these values once we get a response back from the subscription on that observable. So let's go take a look at our page. Okay, we're getting a cannot read property data of undefined. And this is coming from our base chart directive. So this is coming from our library. So let's go take a look at what's happening here. So it looks like maybe it's having trouble getting local chart data. Let's go ahead and try to console.log local chart data here. So indeed, we're getting some chart data back as we would expect. Let's go ahead and get local chart data, and we'll map a new array of the 0th index, and we can check that out. Okay, so we are indeed getting our dates. Likewise, if we map the first index, we are getting our totals. And so I suspect that what's going on here is that we actually need to go take a look at our chart component and make sure that we don't draw the chart before we get our data back. So the way I'm going to handle that is actually directly in the bar chart component. And here we're going to be a little clever, and what we'll do is start ngIf. So if we get our bar chart data back, in other words, this will be truthy. And we'll say also if the bar chart data dot length is greater than 0. Sorry, ngIf, not ngId. So what this will do is it will prevent our chart from being built before chart data actually gets returned from our observable, from the subscription. So let's see if this fixes our issue. And indeed it does. So yeah, so here's our little chart. We can see that on certain days we had significantly more orders than others, but the chart sort of auto scales here. You can see our labels along the bottom, and we can see this sort of popover when we hover over each bar. So that's pretty cool. I think for the next steps, we can go ahead and wire up our pie charts.